Neural networks are very powerful and they are quite popular these days. They are part of a class of machine learning algorithms, which is part of the AI, artificial intelligence techniques. They're very powerful, but the main idea behind this is not that difficult. Here you have your neural network. You put in a lot of data. Over here, for example, pictures of our favorite pets. You put it into your neural network and it will learn from it. Therefore, machine learning. And then you can give it a new picture of a cat that it has never seen before, and it will say, this is a cat. Of course, it seems trivial, but it's a very powerful technique. It's based, for example, in self-driving cars, and Facebook uses it to tag the pictures of your friends. There is, however, one big limitation. If you give it a picture of this nice donkey, the neural network has never seen it before, and therefore it has no idea that this is a donkey, and it will say, I have no idea. So that's a big limitation. It's of course not limited to classifying our furry friends, and you can also use it for other stuff. For example, in chemical installations. Here, you put data from sensors into your neural network, and then it will learn again from it. And if you now give it data on the current state of your chemical plant, then it will give a nice prediction. But again, the same limitation applies. If you give it data that it's never seen before, then it has no idea what's happening. These predictions are very powerful for example, operational decisions. But the problem is that when you're in a state that you've never seen before, then it will fail you. When there's, for example, a big storm that's never happened before is entering a wastewater treatment plant, we have no idea what will happen. When a toxic enters into a chemical plant and everything fails, the neural network will give no meaningful prediction. So the neural network will fail at the moment that you need it the most. Luckily, we have a friend at our chemical plant. Meet Dave. Dave is very smart. He knows a lot of things about the chemical plant and he's been working there over 20 years. And we asked Dave to put all his knowledge into this set of differential equations. It's in fact what you have been doing in ModSim, modeling and simulating of biosystems. And you can use these differential equations to then make interesting predictions. And it's very powerful. It's used everywhere in chemical industry and other stuff, other fields as well. But if we have these differential equations, we call it the mechanistic approach, why do we need these neural networks? Why do we bother with it? The problem is that Dave, of course, is not perfect. He does not know everything. Certain dynamics he's not aware of. Or maybe certain dynamics are too difficult to describe in these equations. Therefore, if Dave doesn't put everything into the model, then of course the predictions won't be good and they won't reflect accurately the dynamics, the behavior of your plant, and then it's also not that useful. So both approaches have their disadvantage. Therefore, it might be a good idea to combine both in a hybrid model. We put our differential equations into our neural network, and then we feed it both the data and Dave's knowledge. Everything that Dave doesn't know, we might find in our data. And everything that's not in the data, hopefully Dave will know. And therefore we will build a better model that will reflect our system better. And this is of course a big, has of course a big impact to applying your model. And that is success. If you're interested in these topics, there are different topics on this hybrid modeling. The first one is applying them to wastewater treatment plants. At BIOMATH we had plenty of data on wastewater treatment plants. We have also plenty of knowledge, so hybrid modeling is the way to go. If you want to do more research into the methodology of hybrid modeling, there's also a topic for you. And if you want, you can also apply it to a system where you have data and knowledge on. But then you should contact me first. And last but not least, there's also a thesis topic together with Doreen where we might apply these hybrid models to reverse osmosis. So if you want to know more about it, you can always contact me at my email address and then we can have a discussion or we can talk on Skype.